Hello everyone. So in last lecture we discussed about statistical analysis of 2q factorial experiment. So in statistical analysis of 2 square factorial experiment and 2q factorial experiment, we directly use expressions for factorial effect total. But there is a one new method which is used to find factorial effect totals in 2 square experiment or 2q factorial experiment, and this method is called as Yate's method of computing factorial effect total. So in today's lecture we are going to discuss about this method. So first we will discuss what is Yate's method and its steps. So this Yate's method consists in the following steps. So we have different steps to find factorial effect total with the help of Yate's method. So our first step is here. In the first column we write the treatment combination. So in this method our step 1 is to find first column and we write all treatment combinations in that first column. So this is our step 1. Then in step 2 we write our second column, and in this second column we write respective treatment combination totals. So we know that when we consider any treatment combination in square bracket, it is a treatment combination total. So in second column we write treatment combination total, and this is our second step. Then in third step we find our third column. So this third column is split up into two halves. Okay. So in first half we obtain by writing down in order the pairwise sum of the values in column 2. So in second column we write treatment combination totals for all treatment. Okay. So in first half of column 3 we write pairwise sum of values which we have write in second column, and in second half the second half is obtained by writing in the same order the pairwise differences of the values in the second column. So in second half of column 3 we write pairwise difference of the values in the second column. So in this way we find our third column entries. Then in step 4 we to complete the next column repeat step 3 on third column. So when we want to find our fourth column, then we use this step 3 to find third column, to find fourth column. So similarly as we discuss here, third column is divided into two halves. In first half we write pairwise sum of values in column 2, and in second half we write pairwise differences of values in second column. So to find fourth column, first we divide fourth column into two halves. So in first half we take pairwise sum of the values in third column, and similarly in second half we write pairwise differences of the values in the third column. So with the help of third column we find out fourth column, and similarly use this step 3 to find fifth column. So in this way these are the steps to find factorial effect totals with the help of Yate's method. So first we will discuss how this method works in 2 square factorial experiment. So in this 2 square factorial experiment we have 4 treatment combinations: 1, A, B and AB. These are the 4 treatment combinations. So 1 represent that factor A and factor B both at first level. This treatment combination A represent factor A at second level and factor B at first level. This B represent factor A at first level and factor B at second level. And AB treatment combination indicates that both factors at second level. So with the help of Yate's table, our first step is in first column write all treatment combinations. So in 2 square factorial experiment we write our all treatment combinations in our first column C1. So here we have 1, A, B and AB. Then our second step is, in second column, write all treatment combination total. So here we have treatment total in C2 column. So treatment total for treatment combination 1 is square bracket 1, then this A, B and treatment total for treatment AB. So in this way we write our second column. Then how we find our third column? First we divide third column into two halves. Then in first half we find pairwise sum of all values of second column, and pairwise in second half we write pairwise difference of values of second column. So here in first half we find sum of these two observations and sum of these two observations. So we get second column like this: A1 plus A and B plus AB. So this is our first half. Since here we have 4 rows, so 2 rows is our first half and next 2 rows is our second half. So here this is our first half. In second half we find difference of these two observations and difference of these two. So we get A minus 1 and last row we get AB minus B. So when we consider difference of two observations, then first write this second term minus this first term. This second term minus this first term. Okay. So in this way we find our third column. So with the help of this third column we find our fourth column. So similarly in fourth column also we divide this column into two halves. In first half we find pairwise sum of values in this third column, and in second half we find pairwise difference of values of this third column. So in first half we find sum of these two and sum of these two observations. So we get fourth column like this: 1 plus A plus B plus AB, and then take sum of these two values. So we get A minus 1 plus AB minus B. Then in second half we consider difference of these observations. So take difference of these two values, and after that take difference of these two values. So we get third value B plus AB minus 1 minus A, that is subtract this term from this term. We get this term in fourth column, and then take a difference of these two values. So we get AB minus B minus A and plus 1. So subtract this third term from this fourth term. So we get this term. So if we observe here, this first expression is nothing but grand total, that is sum of all treatment combinations, or sum of total of all treatment combinations. Then this second expression is for factorial effect total of main effect A, and it is denoted by square bracket A. Then this third term is nothing but factorial effect total for factor B, main effect B, and it is denoted by square bracket B. And last term we get square bracket AB minus B minus A plus 1. So we get square bracket AB, which is factorial effect total for interaction effect AB. So when we discuss statistical analysis of two square factorial experiment, in that I wrote this expression directly, or we can write this expression with the help of expressions for main effects and interaction effect. Suppose we want to remember factorial effect total for this interaction effect AB. Then first remember formula for interaction effect AB, and it is 1 by 2 A minus 1 into B minus 1. Now simplify this bracket A minus 1 into B minus 1 and replace treatment means by their treatment total. So we get this formula, which is factorial effect total for interaction effect AB. So in this way we find factorial effect totals in two square factorial experiment with the help of Yate's method. Now we will discuss this method for 2q factorial experiment. So we know that there are total 8 treatment combinations in 2q factorial experiment. So it is 1, A, B, AB, C, AC, BC and ABC. So 1 represent all three factors at lower level, A represent A factor A at first level, factor A at second level and B and C at first level. So in this way there is a specific meaning for each treatment combination. So first step of Yate's method is write all treatment combinations in column 1. So here we write all treatment combinations in column C1. 1 A, B, AB, C, AC, BC and ABC. So every time write these treatment combinations in this sequence only. Then our second step is write all treatment totals in column 2. So here we have second column for treatment totals and we write all treatment totals here. We know that we denote treatment totals by square bracket. So here is a treatment total for treatment combination 1, then treatment total for A, treatment total for B, treatment total for AB, treatment total for C, treatment total for AC, treatment total for BC and treatment total for ABC. Then our third step is find this column 3. So first we divide this column 3 into two halves. In first half we find sum of all values of treatment total, that is column 2, and in second half we find difference of values in column 2. So first take sum of these two observations, sum of these two observations, sum of these two and sum of these two observations. So here we get first half like this, 1 plus A, and we denote this by U1. Then B plus AB is denoted by U2, C plus AC denoted by U3, BC plus ABC and it is denoted by U4. So this is first half of column 3. Now we want to find second half of column 3 and it is pairwise difference of values of column 2. So here we take difference of these two values, difference of these two, difference of these two values and difference of these two. So we get second half like this. A minus 1, it is denoted by U5. Then AB minus B, it is denoted by U6. AC minus C is denoted by U7 and ABC minus BC is denoted by U8. So in this way we find our third column. Now we want to find our fourth column. So we repeat our step 3 of Yate's method. So this fourth column also divided into two halves. So in first half we find pairwise sum and in second half we find pairwise difference with the values of this third column. So here take in first half take sum of these two observations, sum of these two observations, sum of these two terms and sum of these two terms. So here we get first half in column 4 like this, U1 plus U2 and we denote this by V1. Then U3 plus U4 it is denoted by V2, U5 plus U6 denoted by V3 and U7 plus U8 it is denoted by V4. So this is first half of column 4. Now we want to find second half of column 4. How we find this? Take a difference of these two observations, difference of these two terms and these two terms. So we get second half like this. U2 minus U1 is denoted by V5, U4 minus U3 denoted by V6, U6 minus U5 denoted by V7 and U8 minus U7 denoted by V8. So in this way we find our column 4. Now we want to find column 5. So for this also we repeat our step 3 on this column 4. So in first half we take pairwise sum and in second half we take pairwise difference with the values of this fourth column. So in first half we take sum of these two observations, sum of these two terms and sum of this. So we get V1 plus V2, V3 plus V4, V5 plus V6 and V7 plus V8. Then in second half we take a difference of pairwise difference. difference of these two, difference of these two and these two. So we get second half like this: V2 minus V1, V4 minus V3, V6 minus V5 and V8 minus V7. And this is our last column which represent factorial effect total. So here I have write these terms like this, V1 and U1 format. So how we get these terms in treatment totals? Like this. So here I have write column 4. We get column 4 like this: 1 plus A plus B plus AB plus C plus AC plus BC and plus ABC. And this term is nothing but our grand total, that is sum of total of all treatments. Okay, so this is our grand total. In second row we get A minus 1 plus AB minus B plus AC minus C plus ABC and minus BC. And this term is nothing but factorial effect total for main effect A. And it is denoted by square bracket A. Then in third row we get B plus AB minus 1 minus A plus BC plus ABC minus C and minus AC. So this expression is nothing but factorial effect total for main effect B, and it is denoted by square bracket B. Then in fourth row we get AB minus B minus A plus 1 plus ABC minus BC minus AC and plus C. So this expression is for factorial effect total for interaction effect AB, and it is denoted by square bracket AB. Then in next row we get C plus AC plus BC plus ABC minus 1 minus A minus B and minus AB. And this is nothing but factorial effect total for main effect C, and it is denoted by square bracket C. Then in next row we get AC minus C plus ABC minus BC minus A plus 1 minus AB and plus B. This expression is for factorial effect total of interaction effect AC, and we denote this by square bracket AC. Then in the next row we get BC plus ABC minus C minus AC minus B minus AB plus 1 and plus A. And this expression is for factorial effect total of interaction effect BC, and it is denoted by square bracket BC. And in the next row, last row, we get ABC minus BC minus AC plus C minus AB plus B plus A and minus 1. And this expression is for factorial effect total of second order interaction effect ABC, and it is denoted by square bracket ABC. So in this way we find factorial effect total with the help of Yate's method for 2 square factorial experiment and 2 cube factorial experiment. Thank you.